Hey friends, today we're going to talk about 11:7. Can you multiply and divide radicals? Hang in there with me. We're going to do 11:7 and 11:8, and then you're going to have a chapter test on Friday. To finish up the year, I'm still trying to figure out what to do with chapter 12, but I want you to understand what quadratics are, and I don't think you're going to really learn anything too significant in the last 4 days of class. So I'm probably going to have you watch a couple videos and try a couple test problems. But we'll get to that next week because we do need to talk about Unit 12 in quadratics. But for this week, we're going to finish up Unit 11. We'll do 11:7 today and 11:8 tomorrow. Review on Thursday and test on Friday. All right, so what we have here is 11:7. Can you multiply and divide radicals? Here is what your book kind of wants you to look at, multiplying radical expressions. You're going to follow the same rules that you follow with polynomials. Your FOIL, okay, FOIL. And after multiplying, simplify radicals and combine like terms. So here's your definition for the day. A radical expression is an algebraic expression that contains at least one radical. So let's look at an example of a radical expression. Here's example number 1. We need to simplify this radical expression. Now this looks like one of those crazy problems that, we've got a FOIL. Hopefully you're recognizing FOIL. First, outer, inner, last. So let's look at first. Okay, let me get rid of those. Square root of 7 times the square root of 3. Well, that's the square root of 21. Outer, square root of 7 times negative 6. Negative 6 square root of 7. Inner, square root of 2 times the square root of 3 is a positive square root of 6. And last, square root of 2 times negative 6 is negative 6 square roots of 2. Now we have to figure out if we can combine like terms and simplify. So at this point, I'm seeing a 2, a 6, and a 7. I know they won't combine. 7's prime, 2's prime. They won't break down. 6 will only break down into 3 times 2, so we don't have 2 to bring one out. So over here on the side, I'm just going to first look at 21. 21 breaks down into 7 times 3. 7 and 3 are both prime. So this, my friends, is our final answer. It will not simplify. It will not get any prettier than that. So we will go to example number 2, which hopefully that won't disappoint me in the make it simplify. So here's example number 2. Let me blow that up a little bit. Example number 2 is asking us to simplify this nice expression. Again, we're going to use the FOIL method first. Square root of 5 times the square root of 5 is the square root of 25, which is just 5. Hopefully at this point we're all seeing that pretty easily. Outer, square root of 5 times 7 is 7 square roots of 5. Inner, negative 7 times the square root of 5 is negative 7 square roots of 5. And last is negative 7 times positive 7, which is negative 49. Combine like terms. Look at this. This positive 7 square roots of 5 and this negative 7 square roots of 5 cancel out. This 5 and this negative 49 will combine together to give me negative 44. So that's the simplified answer for example number 2. Okay. Hopefully you're seeing kind of how these examples are all working together in a nice fashion. Let's look at example number 3. This one looks a little bit different. Okay. Now, when we talked about this with polynomials and binomials, I gave you a shortcut. But I also said if that shortcut didn't make sense, just remember that when we have something all squared, it means to just write it 2 times and FOIL. So let's do that. So let's go. First, outer, inner, last. First, square root of 3 times the square root of 3 is 3 because it becomes the square root of 9. And the square root of 9 is 3. All right, so we got 3. Now, outer, square root of 3 times negative square root of 2 is negative square roots of 6. So we've got first, outer. Let's do inner. Negative square roots of 6 again. And then last is negative square roots of 2 times negative square roots of 2, which is positive square roots of 4 or positive 2. So now I see some things that I can combine. I've got a nice 3 and a 2, which would combine to give me 5. And I have negative square roots of 6 and negative square roots of 6, which gives me negative 2 square roots of 6. Remember, sitting in front of each of these guys is a 1. We treat it like a variable. So it becomes 5 minus 2 square roots of 6. Okay? All right, so let's look at this last example for everything. Whoops, I hope I didn't make y'all dizzy with that. Here we go. Here comes example number 4. Example number 4 is just a little bit longer, a little bit more involved, but we're going to do the same thing. But now we have 3 binomials. So we're going to start with the first 2, and then we'll do the last one. So let's go first. Square roots of 3 times square roots of 3 is the square root of 9, or just 3. First, outer, 2 square roots of 3. Inner, negative 2 square roots of 3. And last, negative 4. Oops. All right, now that entire thing is still going to be multiplied by the binomial square root of 6 minus 4. Now let's look at this first polynomial here. I've got a positive 2 square roots of 3 and a negative 2 square roots of 3. Those guys are going to cancel out. And I have a 3 and a negative 4. Those can combine. Look at this, my friends. This makes life easy. That's negative 1 times the square root of 6 minus 4. That is easy peasy lemon squeezy. Just distribute that negative 1 inside there, and it gives us negative square roots of 6 plus 4. And we're done. So what looked like a daunting problem actually kind of resolved itself and was actually a very easy problem. All right, so on the previous examples, we were multiplying. On these examples, we are going to divide. Now, here are the rules for our division. Just like everything else, it gives us nice complicated rules, but don't worry about those complicated rules. You just hang with me and listen to what I say, and you will be fine. All right, so let's look at example number 5 right here. Now, example number 5 is kind of a little bit of a mess because I've told you before that you are not allowed to leave radicals in the denominator. And you see right here that there's a square root of 3 in the denominator. So what we need to do with this is we need to rationalize this fraction, okay? Because it is a fraction. It's a value over a value. Okay, even though there's a plus and a binomial on the top and a binomial on the bottom, it's still a fractional relation, okay, or a ratio. So look at this. We're going to multiply this by 1. So the 1 we are going to multiply by in this problem is going to be the opposite of what is actually sitting in that denominator. So in that denominator is 5 square roots of 3. So the opposite, kind of, if we were thinking of it as an opposite, the opposite of that is going to be something we call the conjugate of the denominator. Conjugate is a fancy word. I'll spell it out over here. Conjugate. Ooh. C-O-N-G-U-G-A-T-E. The conjugate. What that means, conjugate, is kind of like the opposite. So when we multiply by the conjugate, it will become the difference of their squares, and it will eradicate the eradicate the radical, get rid of the radical in the denominator. So what it looks like is if this is 5 plus the square root of 3, this is going to be 5 minus the square root of 3. And since it is 1, remember we have to multiply it by 5 minus square root of 3 over 5 minus square root of 3. So let's do that foiling right here. We've got to FOIL. So I'm going to do the top in blue. First, 4 times 5 is 20. Outer, 4 times negative square root of 3 is negative 4 square root of 3. Inner is 5 square root of 3. And then the last is going to be negative 3, because it would be negative square root of 9, which would be negative 3. Over, I'm going to do the bottom in green. 5 times 5 is 25 first. Outer, 5 times negative square root of 3 is negative 5 square root of 3. Inner, square root of 3 times 5 is 5 square root of 3. And then the last is going to be negative 3 once again. So look at what happens when we begin to combine stuff. Let's look at the numerator. We've got 20 and negative 3. That leaves me with 17. We have negative 4 square root of 3 and 5 square root of 3. That leaves me with a positive 1 square root of 3. Over, look at the bottom. This negative 5 square root of 3 and this positive 5 square root of 3 cancels out. And 25 minus 3 is 22. Okay? So that is as simple as we can make it. So that's exactly what we're going to leave within my radical, okay? So let's look at example number 6 that's sitting here for us. We can use all of this to work with it. Now this sign right here in the middle is a division sign. So I'm going to rewrite this. This looks like the square root of m minus the square root of n over the square root of m plus the square root of n. That's a plus sign. Now to get rid of that in the denominator, I'm going to multiply by the conjugate. The conjugate of this is going to be square root of m minus the square root of n, because I want this sign to be the opposite. If I do it on the bottom, I got to do it on the top, because remember I have to multiply by 1. All right, so now I'm going to FOIL here. First, outer, inner, last. Square root of m times the square root of m is m. Outer, square root of m times negative square root of n is negative square root of mn. Inner, negative square root of n times square root of n is negative square root of mn again. Last, negative square root of n times negative square root of n. A negative times a negative is a positive n. All over, right here, we're going to have first, square root of m times square root of m is once again m. Outer, square root of m times negative square root of n is negative square root of mn. Inner is going to be positive square root of mn. And then last is going to be negative n. Now if we kind of use our magic canceling stick, look, these two guys cancel out, leaving me with, if I simplify the top, m minus 2 square roots of mn plus n over m minus n. Okay? And that's as simple as we can go right now. That is all we can do at this point. So we are done with this problem. Okay? All right, so I'm going to get rid of this real quick because I've got one more that I need us to look at, and it's sitting right in here. All right, so we're going to look at example number 7. And example number 7, once again, we're going to use the conjugate. Okay, so the conjugate, we are going to multiply by 2 square roots of 3, not plus 5, but minus 5. And if we put it on the bottom, we're going to put it on the top because remember, we need to have 1. This is 1. This whole big yucky mess right here is 1. So now we're going to use FOIL. First, outer, inner, last. Let's do it in the numerator. So the first becomes 6 square roots of 6. 6 square roots of 6. Outer, that becomes negative 15 square roots of 2. Inner, that's 4 times 2 square roots of 3 is 8 square roots of 3. And then last is 4 times negative 5 or negative 20. So let's do the bottom. First, I know this is a mess. I apologize. 4 square roots of 6. Square roots of 9. Outer, that becomes negative 10 square roots of 3. Inner, that becomes 5 square roots of 3. I'm sorry, not 5, 10. I just wasn't even looking. Get rid of that right there. Here we go. All right, that's 10 square roots of 3. And then last, 5 times negative 5 is negative 25. So let's use that magic go away pen and let's see what goes away when we do it. These two are going to go away. So let's combine everything else we can, if we can. And here we go. All right, so let's look at the top. The top looks pretty like, oh, that's the way it's going to be. So we've got 6 square roots of 6. I'm going to do that in a different color for y'all because that looks just a hot mess. 6 square roots of 6 minus 15 square roots of 2 plus 8 square roots of 3 minus 20. That does not look good, does it? But it is. It is good. It's okay. It's okay. We can leave it like that. We can't do anything different. Now down here, we've got 4 square roots of 9. Does everybody know square roots of 9 is 3? So that becomes 4 times 3 minus 25. Well, 4 times 3 is 12. 12 minus 25. Hopefully you guys are remembering your sign numbers. Take the larger, subtract the smaller, and your answer has the sign of the larger. So that's negative 13. So this answer right here is, you can just throw the negative sign out front. Negative 6 square roots of 6 minus 15 square roots of 2 plus 8 square roots of 3 minus 20 over negative 13. Now, if you wanted to move that negative sign up into the numerator, that's a perfectly fine thing. You could actually distribute that negative into the numerator right here. That is, a lot of times we want that done for other reasons. And I'll show you what that would look like. We would just distribute it, because remember, negatives can float around. And so our final answer would be negative 6 square roots of 6 plus 15 square roots of 2 minus 8 square roots of 3 plus 20 all over 13. It's a yucky answer, but it's the right answer. All right, y'all. Your homework tonight, hopefully you've seen this already, is 1 through 31 odd. Right here. I made the whole thing move around. Right there, 1 through 31 odd. Try it. Remember, if you are getting the hang of it and you don't need to keep trying it, try what you need. If you have any questions, come hit the Zoom class. All right, bye.